Hello and welcome to SurrealDB stream number 24. Apologies if you had to wait a few minutes there. We'd had some technical difficulties, but we're here now. I'm joined by Emmanuel, and today we're going to be looking at the 1.5 release, and we'll be looking through one of the bigger features in that, which is HNSW indexing. Emmanuel, great to have you here. Emmanuel's currently just finishing off fixing the technical issue that we just encountered as we upgraded to 1.5. But excited to be here. And I guess where we start is, what is HNSW indexing? Because it's known as different things out there in the wild, and to other people, it's probably not known at all. So what is it?
Hi guys, HNSW. So HNSW is an algorithm. The idea of HNSW was to speed up the queries related to vector search and the nearest neighborhood, right? Finding the closest vectors that belong in a space, right? So we already had one index of this kind embedded in SurrealDB 1.0, which was the M3 index that would let you put a lot of vectors and have the benefit of having a faster search with M3. M3 was file-based, so it was stored as a tree, in fact, on disk. It's handy because you can put a lot of vectors, but it's still on disk. And the main difference with HNSW is it's really the fact that it is in-memory structure, really compact, made of different layers, and that provide really good performances with a cost. The cost is the fact that it's an approximation, so you may not have the exact embedding that you want. And so they came with this concept of recall, which is the ratio of right vector that you get compared to an exact neighborhood search. So it's a widely adopted by the industry. It's an algorithm that is widely adopted by the industry because it's only one of its kind that provide that level of performance. And with the cost of being stored in memory. So it's an exciting feature to have in SurrealDB. SurrealDB is already a database that can work on disk, can work on memory, that work in a really different kind of environment. And so it was nice to have already this M3 implementation that was aligned with the logic of beyond disk. But we didn't have something that was efficient in memory. M3 would work in memory, but was not optimized for. And HNSW is optimized. So this is really a big difference.
I guess the biggest question that's going to come to mind is, how is this different from other implementations out there of vector search, and specifically those databases that just focus on vector search? How is this implementation similar or different?
I'm not sure if I get your question. Or is it different between M3 and HNSW, or compared to what?
Yeah, so obviously the differences between M3 and HNSW and what that means to a user. Also, what's the difference between kind of implementation of HNSW, aka vector search on SurrealDB, and those other databases out there, especially those ones that focus on vector search only?
Yeah. The main difference is that the way we usually implement a feature in SurrealDB, we implement operators. So when we did full text search, right, we had an operator. We didn't add a new language or whatever. We just add an operator that you could mix together with other operators. So you put your vectors. So with vector search, you put your vectors the same way you put an array on the database. And you can mix that together with other fields, and then you have the ability just to make a query that will mix together the the vector search and any other filter or any other parameters. You can also mix together ordering, limit, pagination. So it's just another citizen in the big list that we have now. The big operator list that we have now in SerilDB. Yeah. So you can mix that together, and you can bring together full text search, vector search, and any normal data that you will have. So you don't have anymore to synchronize an external search platform on an external vector database synchronized with data that will maybe be stored in a relation database. You can have all in one place, which is really comfortable.
Yeah, there you go. So we've just posted in the chat onto YouTube if you're viewing it there. I'm not sure that goes onto LinkedIn, but we've just posted in a link to the operators section in our documentation. As Emmanuel said, there's a large amount of operators there for working with arrays, indexes, vector search, full text search, object keys and everything. So yeah, so there's a lot of functionality that you can do just using those operators before you even start using functions. Before we carry on, I'm just going to shout out that for those people who are using Surrealist, we've now just released a 2.06. So if you refresh the web page, or if you upgrade to the latest version on the desktop app, and that should be automatic, then you're going to get access to the 1.5.0 release that was just being made this afternoon. That's the latest version of the database. You can run that locally in the sandbox or connect to a remote instance as well. Obviously, the desktop app is going to give you slightly more functionality over the website, only because of some of the functionality we can offer only on the desktop side. So we're going to be sharing Emmanuel's screen in a little bit and walking through some of this HNSW indexing functionality. And that is going to be using the new Surrealist, which we announced just at the end of last month, and connects into 1.5.0. So if you're listening into this stream and want to follow along, then yeah, just download the latest Surrealist. So I'm going to share Emmanuel's stream now, and let's kick off this demo. Yeah, so it's simple. So I would like to make a complex demo, but in fact, the way it's integrated makes the things pretty simple. So the first thing, and it looks like a rhetoric message that we bring, but putting a vector in SerilDB is pretty easy, right? So we use the create command as usual to insert any data, and we can insert points. So the way, so yeah, I'm just going to create. Hopefully it's working, or everything is working. So I'm just putting 3 vectors, 0.1, 0.2, 0.2, right? Pretty random. I mean, not random, but vectors. So just to clarify as well, these vectors can be arbitrary length, can't they? They can be 3, but they can be 1,500.
They can be 1. They can be 1. They can be 2, 3. They can be in thousands. Surprisingly, we and I didn't expect that to happen, but we have someone that tried to inject 1 vector of 2 million of dimension. So I'm not saying 2 million vectors, right? I'm saying 1 array or vector of 2 million dimensions. So he reached some limitation at some point due to the WebSocket connection. So he was able only to put a vector of 1.9 million each item. But we give him a way where he could, because with SerilQL you can append an array to an array. So we give him a workaround so he could bypass this issue due to the maximum size of a message in WebSocket. So yeah, so you can even put that may not work well with the indexing, but we didn't yet try. But this is not the normal use case, right? The normal use case is to have hundreds, sometimes thousands, and we start working with the ANN benchmark, which is the reference benchmark for that kind of indexing, and we work with usually with vectors between 100 of dimension of 100 to thousands. So yeah, and it covers most of the model that you may want to use.
Just to clarify, so OpenAI's vector embeddings are 1,536 on the smaller side, and then 3,072 on the larger side. So definitely thousands, not millions range.
Yeah, so you could embed OpenAI in SerilDB. We haven't tried yet, but maybe we will have the opportunity to do that. Okay, so talking about dimension, this is one of the parameters that is required by the index. So we create an index as usual, define index, we give him a name, the table is going to index record from, the field that contained the embedding. Then we say it's an HNSW index, which is the name of the index. And then you can pass different parameters. So of course it could be interesting if you are working on AI and vector search to look at the paper and to see what they suggest. You can also have a look at the ANN benchmark. You can have some indication about which parameter are interesting. And it's all about the recall, right? The precision and that you want related to the approximation of the search. So in this case, we just put a dimension of 4, which is the size of embeddings. We give the distance. Interesting thing also with HNSW, we support now I think 12 different kind of distance. I mean, mostly probably all the one you need. So Euclidean, Manhattan, Minkowski, cosine, Pearson. There's a lot. So mostly every vector function that you can see in the documentation that are here, distance and similarities are supported by HNSW. So that's really cool because you can really try many different kind of model. Something new that was introduced also for M3 on 1.5 is that now we can give the type of the vector. So it's an optimization, because before that we were using by default 60 bit, so a float of 60 bits. And because it's in memory, of course, it was using more memory that we would not like. So now it's possible to use F32, or if it is integer, you can use E64, 32, and 16. So it's a way to optimize your consumption in memory. EFC is a parameter from HNSW, which give the precision or how deep the tree is built. Again, I would be happy to talk about this because we made an ad hoc implementation of HNSW, so we have a good sense of what it means. But reading the paper, which is not that long, will give you some good information about what this means. And M12 is also a parameter of the algorithm. A typical value would be 8, 12, 16. So these parameters have to be provided. There is other parameters that I explain in the documentation that are parameters that belongs to the algorithm. So for the one that really wants to make us really in-deep customization, you have all these parameters available, including the heuristic, which is the method of calculating the neighbors in the algorithm. So you will see on the documentation that we provide all the capabilities that the paper is describing, so you can find the best fit depending on your model. So let's create the index. Let's go for it.
I think what's clear from all of this is the flexibility that you have and the configuration options you have for every search and every index. And I think it's important to note as well that you can have your vectors stored within your records. They don't have to be stored separately. They're actually stored, the data of the vectors are actually stored right within your records. And you can have multiple vectors on a record. You could have multiple indexes across different fields and different columns alongside. And that gives you an incredible level of flexibility as a developer and as a user. Isn't that correct?
It's absolutely correct. Yeah, absolutely. I mean, this is the power of SerilDB, which is multimodal, right? And multimodality is exactly what this kind of features showcase, definitely. Let's do the query. So Serialist has been launched or presented recently, and it's really a pleasure to play with. So the operator that you use for KNN is it ends with greater and so what is the first one? Sorry,
less than
and a pipe. And look how it looks well with Serialist, where you have this little triangle. So it's really nice, and I discovered that today, and it's absolutely a nice feeling to see the code this way. So we can run the query now, and so the query. What is the query? Here it's a select, a normal select, right? Here I have added the distance, but we don't need it, right? I just put that because it gives some information and showcase that the query is right. But we can just return the point and give here the goal, which is a number of items that we want. We could just decide to have one. And this is the EF parameter on the search. So it is the equivalent of the EF parameters that is built when we build the index, and the EF give you the ability also to change the precision of the search, if I can say so. So this is the two parameters that you need when you use HNSW: the number of records that you want to return, and the EF search applied to the search. And that's it. And I have my query running. I have also the function that I can use here to return the distance if I need it. And of course I have, as usual, the explain. If I look at the explain, I can see in the explain plan that my index has been used. The plan say I'm using the index called HNSW point. The operator has been 2,100. This is the value that was given, and I'm iterating an index, which means I'm iterating faster than I'm not browsing the whole table, which is what we expect from the index. Yeah, that's it. And once you have that, then it's just a matter of putting your vectors and making your queries.
Yeah, that's awesome. So when you combine this with other conditions in a where clause, for instance, as one example, this allows you to use the index if it makes sense in the query planner, and then to actually combine that search of the vectors with other attributes, other fields, nested objects, nested array fields, everything like that. Yeah, is that correct?
It is. What is interesting regarding this is, and the community, and thank you guys for giving feedback. So the community start playing with the M-tree, because M-tree is available for some time now. And we have feedback from you guys. I will give an example where we are going to improve again this. So HNSW is beta, right? It's on 1.5 beta, because we know that there is still some improvement to do. And I will give you this example there. So if I add another information like a Boolean, let's say this one is true, this one is false, and this one is true. I can indeed mix now in my query where point, and I can also say I just want the one where flag is true, and I can mix that together. Okay, here we go. Is it yeah, of course. Is it the beta effect? I'm not sure. Let's go for this. Yeah, I think it's beta effect. I didn't check that before, guys. So maybe I'm not sure if I did something wrong. I don't think I did, but let's make that again. Okay. In theory, this is what we can do, right? So we will check that after, maybe follow up after the live stream about this. But yes, you can mix together this operator with other parameter. The thing that has been reported by the community is that when we do that, this clause will return, as example, two records, and this clause will return two other records. And what you get at the end is an intersection between those two predicates, which may be only one item. And what you usually want to do with, or sometimes you want to do with KN and search, you still want two. So you would like to have the two with the flag set to true. So we are going to change to improve that by just removing this and allowing to use limit. So by doing that, it will be possible for the algorithm to change the way the execution parameter is done, and then to indeed have the right filter. So, and this will be available on 2.0. It's not yet available on 1.5. If you look on the issue, there is an issue that is related to this, and we show a workaround for people that need to separate by using different collection, which is pretty easy to do with a table, I would say, with a LDP. Yeah.
Awesome. So we're going to jump into a few questions from the community.
Yeah.
Let me go up a little bit. So we've got, hold on a second. All right, so we've got one here from Alex. Alex K, great to have you with us. Thanks for the question. So implemented limits for parsing depth in the new parser. So obviously this is from the 1.5 release notes. What are those limits? So what we're progressing towards, and I don't think actually that the new parser is used in 1.5 yet. The new parser is an experimental feature that you can enable in the Rust library and on the server, but actually this new parser is coming in version 2.0. Behind the scenes, the parser is completely rewritten from scratch. So let's just hide this screen. We'll come back to that. So yeah, so the parser is completely rewritten from scratch now, and in it we have implemented a new library that asynchronously handles every task and ensures that task can never overflow the memory stack of the execution of that machine. So in effect, what we've got is we've got better security around the parser itself, better stability, but it also means that some of those limits that we had before, which were hard-coded limits and relatively low, if that makes sense, they're now higher because we can be sure that we don't reach a memory overflow when those functions or when the depth is traversed to a certain extent. So really when the version 2 parser comes out in version 2 of the database, you'll actually see increased limits and increased ability to have nested objects, nested arrays, nested functions, nested subqueries and things like that. For a few things, there will be hard limits still. There's going to be a hard limit on the number of subqueries deep that you can run. Probably won't ever get to that point because 20 subqueries is probably questionable about whether you're doing the right thing. And then for objects, we may have a hard limit at 100 or something like that for nested object depth. This is something that can be configured maybe as an environment variable. But yeah, so those are general thoughts. So actually the parser limits will actually be increased and there'll be a better stability around the parser and how it runs. If I didn't answer your question correctly, or there's something else you want to know, then please follow up with another question. Sajad, great to have you with us as well. Sajad asked, will fuzzy searching be added to Surreal? So this is a question about fuzzy searching on the full text search. You've asked the right question on the right day because Emmanuel is the genius behind that side as well. So we'll jump in and answer your question on fuzzy search specifically. There was one other question around that actually, which is so I wanted to ask about fuzzy searching. I played around with a full text search, but it doesn't take into account misspelling. I think to answer that question, I'll let Emmanuel answer it, but you have to understand exactly how full text search or fuzzy search works. And then one other thing I'm going to say before Emmanuel answers is there's the full text search indexing functionality, which has the understanding of stemming and therefore can give you some element of fuzzy search. And there's also the fuzzy search operator, which doesn't use indexing at all. It's a brute force method, but it gives you the ability to completely fuzzy text lines of strings in a similar way to how the file name search in VS Code works. So yeah, Emmanuel, I'll let you answer correct. Let's put it that way.
I mean, your answer was already correct. What I just want to add is that we already included, in fact, the way we build the index prepared us to have the support of Levenshtein. So Levenshtein is the algorithm we use for fuzzy usually. So it's there, but not activated yet. So we are using this automata that include Levenshtein and also regular expression, because you will be also able to have the benefit of the index using regular expression. So it's in the roadmap. It's not yet there, It may not be there yet for 2.0, but it's on the roadmap. It's for the full text search and will be there soon. I will try to give more visibility, but it's not in the roadmap. I'm going to be there.
Awesome. And then just to add to that, so the fuzzy search operator is effectively the tilde key. So you can let me just share this screen actually really quickly, just to give an example. So hang on a sec. There you go. So what you can actually do is you can say select all from person table where name or email, let's say, is like gmail.com. Now this goes and finds anything which matches. It's brute force, so it's not really using an indexing behind the scenes, and it doesn't use an index at the moment, but it'll go through and find any record which contains gmail.com. Let's say that a person has a name which is like that. So what this will actually go and do is you could say select all from person where name is like T Hitchcock, and that would actually also find this record which has this name. So it's very similar to what you can when you're typing to search for a field in VS Code. It'll find and match similarly to those documents or those files that have some elements or most of the elements of your search. So in this case, you don't have to put in percentage signs or anything like that or regular expressions. It will match across the value and pull out the ones that are relevant. So as I say, that's not really an alternative to fuzzy searching in a full text search index way, but it is an alternative that you can do. And just to add to that, if you jump into our operators page, we also have this character, and we also have this. So if for instance you want to search through an array for any item that might contain or might match this string, then that will be all items have to match or an item has to match. So there's a fuzzy matching operator for arrays as well. Anyway, let's carry on with Emmanuel.
I have a great feature to show as well. Do you want to share my screen?
Yeah, let's just switch to you.
I mean, guys, 1.5 comes with a lot of things, and it was difficult to select what we would showcase today in this live stream. But one really cool thing you guys like a lot, and we do as well, the graph capabilities of CyrilDB with the record link. And until now, the record link may require, depending on the query you are doing, to parse the whole table. So what was missing was the ability to make, in some case, an index that could speed up the query. So we now have. I know that often we say we don't need join, right? And most of the time, and Toby will explain that perfectly, much better than me, but most of the time there's many use cases where join does not make sense, and sometimes it makes sense. And here, when we want to filter on a record, if the record is indexed, and this is new, this is introduced with 1.5, then the query is going to be faster. And we call that join because it's a kind of join, in fact, behind the scene. So if I show quickly, you can recognize that when I run this query. So I did it already. On the explain plan, as usual, we do an explain. You can check that the accelerated strategy due to the query planner and the execution plan is triggered. The operator is called join. So when you do that kind of query, where you search for the name on the record link. So I use t.name, which means I'm looking for the name on the join record, if I can say that this way, but maybe Zombie you want to use better word than me. And so this query previously was not optimized in the way it was running, but it was not be able to use an index. So now this is detected, and it uses an index called join.
Yeah, that's awesome. I didn't know that, Emmanuel. So that's actually effectively what it's doing. It's changing the query planner, so it's looking at the other table first and then working back from there to. So it's using the index on the foreign record and then working back from there to pull out those records potentially because they don't have an index on that. That's really cool. There you go. You learn something new every day. That's really exciting.
And what is interesting there is that there's some use cases where this can be faster, some other use cases where it may not be faster depending on the cardinality and different factors. So you can use without indexing the select clause to disable that. So the things to do when you have these capabilities is to always have in mind that to have a look at the execution plan, to benchmark also the execution of your query, because sometimes the index may be faster, sometimes not using the index may be a better option.
Yeah, definitely. Just to come back, Sajad, yeah, so definitely if you want to search millions of rows with full text search, then you use the full text search indexing, and we'll be adding more support for different operators and different functionality as we go along. But you can already use that. Already use that to search through millions of rows in a very short amount of time. Just don't use the brute force fuzzy search operator at the tilde character just yet, because that won't do that. It won't use an index. But yeah, that's we'll be improving on on vector search and full text search indexing across every version, every release. We've got another question here, Emmanuel. So Caleb, thanks for the question. What is a good way to ingest large amount of vectors?
So we are running actually the ENN benchmark, right, to be sure that we are as close as possible at what the industry want to achieve as terms of performances, both in ingesting and querying. So in ingesting, there is something that you want to do, which is grouping your vectors. So you can, we do that so with ENN benchmark. What we do, we ingest, depending of the size of the vector, and of course, depending of the limit on the connector. If you use WebSocket, you use HTTP, you may reach at some point some limit due to the size of one query. But you can usually group hundreds and sometimes thousands of vectors together. So if you do that, you go much faster, because in fact, ingesting hundreds or thousands of vectors go not much slower than just ingesting one, because we pay a bigger cost to establishing the transaction, because again, SerialDB is ACID, which is really powerful. And so each time you can make that kind of grouping, you have the benefit of making that in one transaction. And this transaction is not only, sometimes some people think it's slowing down, but it's also speeding up, because when we open a transaction, we have a way, a motorway to put data inside the database. So yeah, group your vector together. If you can do that, put them 100 by 100 and make some bench to see how far you can go depending of the connector you're using. But yeah, this is what we do, and it goes pretty fast.
Awesome. And Caleb, just to add to that, we've got lots of different statement types. So you can use create, which only allows you to create a single record, but you can use insert to insert an array of records. So you can insert 1,000 or more at a time. And we've got support coming for batch relation as well. And that's slightly different to the question, but so there's lots of different ways of inserting or batch inserting large amounts of data already. And we've got more plans for adding additional functionality on that side soon. So yeah, hope that answers your question. If you've got any other further questions on that, just drop them in the comments. We've got another here, one from Chase. Chase, thanks for the question. I'm going to guess you mean graph recursion here and arbitrary depth recursion of graph queries. If you don't, then drop it in the comments and I'll change my answer. But for graph recursion, yes, we definitely do have plans for recursive queries and arbitrary depth queries. This is more, it's not so much a challenge on the execution, query executor layer. It's more a challenge on how we present this in the query language and get this in a way that we really want to work well. But yeah, definitely support for graph recursion and improved graph functionality is on the roadmap, and hopefully sooner rather than later. Yeah. Awesome. Just one other question before we jump back into the release notes of 1.5, because there are quite a lot of things that look quite small but actually are quite impactful. Gary, thanks for the question. So is there a plan for schema and data versioning or something like migrations directly in CerilDB? So there isn't right now, but obviously we know this is a missing piece of the puzzle on CerilDB, and it's something we are working on improving as we speak. So we do want to have the ability to migrate data right inside CerilDB command line itself, so that you can handle migration and data upgrades. The challenge on CerilDB's side is we have to think about embedded databases and single node databases that are relatively easy to upgrade. And we also have to think about databases that are running on TiKV and potentially have 4 terabytes of data. And obviously how you handle migrations in CerilDB is very different depending on the size of data and the size of the database. So yeah, that's definitely something we're going to be adding to Cereal. And you as a user will have the option to pull that right into your continuous integration pipelines or your development workflows, but at the same time have the option to determine how it affects your database in a production environment, depending on what you're updating, fields or data or changes like that. So yeah, absolutely not yet, but definitely planned and on the roadmap coming soon. That's all the questions so far, Emmanuel. So let's jump back into some of the big releases for all the big features in 1.5.
Yeah, I will not be able to showcase this one, but I can talk about it.
Let's do it.
Because guys, so Cereal has to connect with your local instance, and it was not running on my environment. Let me explain what we are talking about. We are talking about a new feature called temporary table. I mean, we call it temporary table because it's close to what usual databases are doing. So
this is a big one, isn't it? This is a very big one.
It's a big one, and it was something that provided some from time to time out of memory for people reaching those limits. So the thing is simple. If you have your record on disk, on TiKV, on RocksDB, you may have a lot of records, and you may decide to make aggregation. You may sometimes have queries that has to browse maybe the whole set collection, I mean the whole set of records. And until now, we were bringing those result sets in memory. And because we do that in a pretty clever way, it could work, but from time to time, you may reach a situation where it does not fit anymore in memory, and you end up with out of memory. Which works well. In fact, we don't have this problem where you're using an instance in memory. On disk, that can happen. So we have now something called hybrid temporary table. The thing is that once you have a query that goes over 50,000 records, which is a value that you can change using an environment variable. Once we reach that, then we decide to store the result set on disk. And we use that in a pretty clever way. I mean, we store that and we sort it in the same time, which allows them to make pagination or to retrieve then the content already sorted. It's pretty fast and goes pretty well. But what it allows is to make this computation possible, where before it will end up with out of memory. So we call that, so it's transparent. So you have nothing to do. The only things that you have to think about is that then you have another directory where we store these temporary tables, which is not the same directory where your data are. So by default, we use the temporary directory on your environment, but you may, for security reason, if you run that on the cloud, you may have also to set the directory. So think that there is a parameter for that, and also an environment variable. So yeah, it's allow to make those long query because they are probably going to browse a lot of data, but that's possible, and it was not possible before. And added to that, something that have been introduced also in the previous version of Cyril, but mixed with this feature, you have aggregation, which are optimized aggregation. When you do put those two capabilities together, you can make really, really big aggregation working where they could fail. So yeah, so there were some issue open. So if you look on GitHub on CyrilDB, you will see that there is some issue that were saying that they reach this out of memory problem, and most of the time those issues have been now solved, and we expect to see you guys on the issues confirming that. And so 1.5 should be the release that solves this kind of issue.
Awesome. I think there's a few lots of little things as well, like that we've added into to 1.5. One of the things is dropping or enabling, support for parameters in relate statements. So now you can relate from something, and that can be a parameter, to, with, and that's the graph edge, as it were, and that can be a parameter, and the foreign table can be a parameter. So now you can have a record ID, a table, and a record ID as parameters, and you can put those into your relate query. And you could also have arrays and different things like that. So lots of ways of improved ways of working with the relate statement. Just looking through the release list as well, we've added a new info for table, database, namespace, scope, structured statement, and that gives you with a kind of JSON breakdown of the structure. Now we use this internally in Surrealist, but you can also build on top of this effectively. Instead of just receiving the text, the SQL, the defined statement as text, you get to now see a breakdown of that, which means you can much more easily understand what the configuration is for any of those levels. So info for database, info for namespace, info for table, and info for scope. Lots of improvements here that I haven't really gone into the release notes, but performance improvements, bug fixes, and things like that. And lots more coming in the next release as well. So yeah, really excited about that. Emmanuel, any wise parting words that you have on the vector side or anything like that?
Any wise? Say that again. Any wise?
Parting words.
I'm not sure I understand what you mean. So it's
any final words.
Final words. Oh, please put vectors in database and give us feedback. I mean, yeah, we want you guys to play that with that now, because we know that there is a many fancy application to do with. So and we want to put that really. We want to be sure that CyrilDB you can put your models, play with. And so we want you to do that and to get feedback about limits that you may encounter, and we are willing to fix them really quickly. And you probably know that we go pretty fast in fixing things and improving. So, but we can do that because we have your feedbacks. So please give feedbacks.
That's well said. If you're not on our Discord, then jump on our Discord here to ask any questions. Other than that, as Emmanuel said, please play around with vector search, play around with some of the new functionality in 1.5, and jump onto our GitHub at github.com/CyrilDB. Jump onto the main repository at /CyrilDB again, and add any bug requests or bug suggestions or feature requests and anything else you might have there. Obviously, without your support, your additions, your suggestions, and CyrilDB wouldn't be what it is. So yeah, thank you for those who already have, and looking forward to any future ideas or bug finds that will help us make this even a better product. Emmanuel, thank you. This has been really interesting. Really looking forward to see what people build on top of SerilDB using the vector search functionality and all the other functionality along with it. And thank you to everyone who's joined us today. If you've got any other questions, then do ask us on GitHub or Discord or in these comments on this stream, and someone from the team will be reaching out and answering. And that's it from us today. So thank you, and see you at the next stream. See ya.